What's going on, guys? Today I'll be going over lecture 9. I'll talk about the Schrödinger equation, Max Born and de Broglie's ideas, Heisenberg's uncertainty principle, orbitals, and electron configurations. But first, a fun fact. Did you know a dog has around 19 grams of protein per 100 grams? That's why we eat chicken. The Schrödinger equation tells us how tiny particles, like electrons, behave at the quantum level. Instead of moving in clear paths like planets around the sun, electrons act more like waves. The equation helps us predict where an electron is likely to be found. It is an equation of quantum mechanics that describes how the wave function, a system, evolves over time. Max Born and de Broglie also helped explain why only certain orbits can exist. De Broglie proposed that electrons and other particles behave like waves, introducing the idea of matter waves. Born refined Schrödinger's wave equation and proposed a new way to interpret the wave function. He stated that the wave function squared represents the probability of finding an electron at a specific location. Their ideas led to the modern concept of electron orbitals and probability distributions around the nucleus. The Heisenberg uncertainty principle states that it is impossible to precisely measure both the position and momentum of a particle at the same time. Instead of neat paths, electrons exist in probability clouds called orbitals. Summarizing the ideas, electrons don't move in fixed paths like planets around the sun. They act like waves and can only exist in certain energy levels. And instead of pinpoint locations, electrons exist in probability clouds around the nucleus. That is why we use orbitals. Orbital energies refers to the energy associated with an electron in a specific orbital around an atom's nucleus. The energy of an orbital depends on several factors, including its distance from the nucleus, electron-electron interactions, and shielding effects. Electrons in lower orbitals closer to the nucleus have lower energy, while those in higher orbitals, which are farther away, have higher energy. In addition, the nucleus pulls electrons inward due to its positive charge. Inner electrons repel outer electrons, reducing their effective attraction to the nucleus. Shell's or principal quantum number n represents major energy levels. The higher the n level, the higher the energy. In the sublevels, which are the s, p, d, and f orbitals, each shell is divided into subshells with different shapes and energy levels. Orbital energies determine how electrons are arranged in an atom, affecting its stability, bonding, and chemical properties. Lastly, electron configurations. Every atom has a nucleus in the center, surrounded by electrons, but these electrons do not float around randomly. They are arranged in specific energy levels called shells. Each shell can hold a certain number of electrons, and within these shells, there are subshells. These orbitals have different shapes and can hold a specific number of electrons. The s orbital can hold 2 electrons, the p orbital can hold 6 electrons, the d orbital can hold 10 electrons, and the f orbital can hold 14 electrons.